Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is grid reinforcement in soil. In reinforcement, till now, we understand what is soil reinforcement, what are the reinforcement with strip. These are the different kinds of reinforcements for getting the better soil properties or required soil properties based on the project. Till now we understand, in previous our lectures we understand the how soil reinforcement and their types, and also the reinforcement with strip reinforcement conditions for the soil we understand. In this lecture we are going to understand the what is grid reinforcement, which is helpful for the better soil reinforcement. In this reinforcement, the soil reinforcement involves incorporating of materials into soil, enhance its mechanical properties. Those mechanical properties are strength, stability, deformation characteristics. So this is soil reinforcement for the purpose of improving the load bearing capacity and reducing the settlement and the deformation. In reinforcement, n different number of reinforcements are available in these geotextiles, geogrids, geocells, and steel reinforcement are the different types of reinforcement till now we understand. In these geotextiles, we are using the fabrics used to separate, filter, reinforce and drain, and also geogrids. It's a grid-like materials used primarily for reinforcing soil. In geocells, cellular structures that confine and reinforce the soil. In steel reinforcement, bars or mesh abandoned within the soil we are using for getting the desired soil properties. It involves n different number of materials to enhance the various mechanical properties of the soil. So that is the soil reinforcement. In this, the grid reinforcement is nothing but the different types are involved in this geogrid. The grid reinforcement, the name itself tells us, in this based on the grid parameters, the grid way of structures we are introducing in reinforcement in such type, that reinforcement is known as grid reinforcement technique. It is the one of the soil reinforcement technique. So in this technique we are using, in this technique also we are enhancing the soil properties, but based on the scenario and the desired properties and which type of construction we are choose. Those are the conditions are driven to choose the grid reinforcement. In this geogrid, a type of reinforcement material that consists of a polymeric grid structure. So the structure itself in terms of grid, that reinforcement comes under soil reinforcement technique. So whenever the grid structure is there, such reinforcement is known as grid reinforcement for better or enhancing the properties or desired properties of the soil for construction purpose of the particular region. It is used to reinforce soil by providing tensile strength and confinement. So in this geogrid, we are used to reinforce soil by providing the tensile strength and also confinement. In geogrids, different types are there, that is uniaxial geogrids, biaxial geogrids. In uniaxial, the reinforcement soil in one direction typically used in retaining walls and slopes. In bioaxial geogrid, reinforces soil in two direction, commonly used for road construction and also the embankments. In one direction, the kind of grid reinforcement we are using for retaining walls and slopes. In such cases, we are using uniaxial geogrid condition. Whenever road construction, embankments, we choose this bioaxial geogrid. Coming to the mechanism for the action of the grid reinforcement in soil, in this tensile, interaction with soil, load distributions are the parameters for understanding the grid reinforcement. So in this tensile strength, geogrids provides tensile strength to help transfer loads from the soil to the reinforcement. It improves the stability. So this is the mechanism of action, one of the in grid reinforcement. In interaction with soil, the interaction between the geogrid and soil increases the frictional resistance, which contributes to the overall stability of the reinforced soil mass. In load distribution, once the grid structure distributes the load over how much the area is occupied, or the wider this area, that reduced the localized stresses and potential failure of the zones. These are the mechanism of actions for grid reinforcement in soil. In this grid reinforcement in soil, various design considerations are involved once before designing the grid reinforcement. So we have to consider load transfer mechanism, in that direct load transfer, and also the frictional resistance. So in this load transfer mechanism, throughout the geogrid itself, it helps to redistribute the loads within the soil mass. In frictional resistance, the interaction between the soil and geogrid creates frictional forces that enhances the stability. So in this load transfer mechanism is one of the major parameter in grid reinforced soil as per the design consideration. So we have to understand the load transfer mechanisms based on the soil conditions and the required properties of the soil for type of construction work. So in this design parameters are there reinforcement material properties, soil properties, reinforcement spacing, geometric arrangement. So these are the some of the key design parameters which we are going to consider for this design of grid reinforcement. In these reinforcement material properties, so we are considering different types of materials and we are choosing it as per the desired requirement. In that, tensile strength and modulus of velocity and durability are the important properties which we are going to consider. In this soil properties, cohesion, friction angle and density are the important parameters for grid reinforcement design considerations. We have to understand for conducting some simple tests using laboratories or inside test equipment, we are going to understand this cohesiveness of the soil and also the friction angle and density. And also, once we understanding all these properties and load transfer and also the frictional resistance, all these mechanisms, once we conclude all these, now we have to move on to the reinforcement spacing. The spacing between the grids is as well as vertical and horizontally the how much grid and the layers. So that is also affects the load distribution and also the overall stability of the structure. So according to this, the distance between the geogrid layers which are affects load distribution and also the stability. In geometric arrangement, layout of the geogrids within the soil mass. So these are all the some of the consideration we have to consider for the design. In this, based on these consideration, now we are choosing the method of the design. In that, limit equilibrium method and finite element analysis. So these two are helpful for the designing the grid reinforcement. So in this limit equilibrium method, we are going to analyze based on the equilibrium conditions. Stability, the property of stability, we are going to analyze using the equilibrium condition. In FEM, that is nothing but the finite element analysis, FEA, numerical methods are used to model the complex interaction between the soil and its reinforcement. So these are the design consideration, and we are choose the design method as per the required, as per the what are the given things and the final results based on the conditions we are choose for the based on the method. So sometimes equilibrium methods are enough for analyzing the stability. In some of the situations we have to use the numerical methods for analyzing. In this, grid reinforcement is going to use in different structures, that is earth retaining structures, pavement and road construction, embankments and earth dams. So in this earth retaining structures, retaining walls and reinforced soil slopes, we are going to use this grid reinforcement. In retaining walls, use of geogrids to stabilize the backfill and prevent wall failure. For this purpose, we are using grid reinforcement. For in reinforced soil slopes, enhancing the stability of natural or constructed slopes. In road construction, subgrade reinforcement, so improving the load bearing capacity and reducing deformation of road subgrades, and enhancing the structural performance of the base layer in pavements as part of base course reinforcement. This is, we are using the grid reinforcement. In embankments and earth dams, in embankment stability, increasing the stability and reducing the settlements of the embankments, we are going to choose this grid reinforcement technique for getting the stability of the embankment. In earth dams, reinforcement of soil in earth dams to prevent failure and erosion. So these are the some of the application and major applications of the grid reinforcement technique. Construction techniques, in these installation methods, so placement of geogridding compaction techniques are there in this installation method. Proper placement and alignment during construction to ensure effectiveness. In compaction techniques, compaction of soil around the geogrid to achieve desired density and stability. In quality control, inspection, that regular inspections of the geogrid placements and soil compaction is important for proper maintenance as well as the long-term stability for the structures and the meet the requirement of the structure using this grid reinforcement technique. In testing, conducting field and laboratory tests to ensure compliance with design specifications. Successful applications of case studies for grid reinforcement is reinforced earth retaining wall in highway projects. So for that conditions, this type of grid reinforcement is helpful. In geogrid reinforced embankment for a rail line. So these are the case studies which we are consider, and also the challenges are also there in grid reinforcement. Those are common issues we are faced during the installation and their solution. It is difficult to install and their solutions. Recommendations for effective design and construction of reinforced soil structures for better practice of this technique. Final summary of this grid reinforcement. So it is importance of reinforcement, how grid reinforcement improves the soil stability and performance. In future, advances geogrid materials and technologies are helpful, and in further, some of the web references are available for understanding these ground improvement techniques. Thank you. We will see in our next lecture.
Like, share and subscribe. Hit the bell icon for more updates.